In the previous video, we introduced the concept of determinants. We discussed how to calculate, how to evaluate 2 by 2 and 3 by 3 determinants. And as promised, we're going to use the determinants in order to show you how to define the cross product. So here's our definition for the cross product of two vectors. V with components v1, v2, v3, w components w1, w2, w3. What you do for v cross w is that you form a 3 by 3 determinant where the second row you put in the entries from v, the third row you put in the entries from w, the components of w, and in the top row you put literally the vectors I hat, j hat, and k hat, the three standard basis vectors. And then you evaluate this determinant. If you want it, if you crunch it out, an alternative way to give the definition of the determinant, or sorry, the definition of the cross product, which is exactly equivalent, is through this formula down here. Is I hat times v2w3 minus v3w2, where those are components of v and w, plus j hat times this, plus k hat times this. This is our definition for the cross product. Before I do an example of the cross product for you, let me just emphasize one thing here. The cross product is only defined for vectors in R3, vectors with 3 components to them. To go back to the dot product, we can take the dot product of 2 vectors in R2. We can take the dot product of 2 vectors in R3. The cross product is only for taking the cross product of 2 vectors in R3, has no meaning in R2. Okay, so let's go ahead and do an example here. So let's calculate out v cross w for these 2 vectors here. 1, 3, 5, 2, 0, 1. So v cross w, I'm going to write down a 3 by 3 determinant. So the very first row is always in a cross product calculation. Just the 3 standard vectors, I hat, j hat, k hat. Then our second row, we're going to write down the components of v. In our third row, we're going to write down the components of w. Okay, so now to do this calculation here. So from how we know to evaluate 3 by 3 determinants, it's going to be I hat times, cross out the first row and column here. And so times the determinant of 3, 5, 0, 1, minus, remember this middle term always comes with a minus sign attached to it. J hat, cross out the top row and second column, and we have left over 1, 5, 2, 1, plus k hat times, cross out the top row and final column, and we have k hat times 1, 3, 2, 0, that determinant. Okay, so now we just have to evaluate each of these determinants in turn. So I hat times 3 times 1 minus 5 times 0, and that's just going to be 3. So 3 I hat. J hat term down here is going to be 1 times 1 is 1, minus 5 times 2, 1 minus 10 is negative 9, times that negative sign there is plus 9 j hat. Finally, k hat times 1 times 0 is 0, minus 3 times 2, negative 6 k hat. So this is our, so our final answer here is 3 I hat, comma 9, comma negative 6 here. Okay, so let me also point out that we could have used this formula down here to compute things. So that would have been, let's just do it this way, I hat times V2W3, 3, 1, 3 times 1 minus V3W2, 5 times 0. And note here, 3 times 1 minus 5 times 0, that's exactly just the determinant calculation that we did before. Plus j hat times V3W1, so 5 times 2, minus V1W3, 1 times 1, plus k hat times V1W2, 1 times 0, minus V2W1, 3 times 2. And if you do this, you get to the same exact place. Okay, so let's have you do a pre-class problem here. So find the cross product of these two vectors for for positive 5, negative 2, and v is negative 3, 0, 1. You are welcome to use either way to compute the cross product here.